Okay. Find all that. Okay, classification. So yesterday you had a worksheet and you were able to, you classified numbers, right? So you had natural numbers, whole numbers, integers, and that gave you the set of rational numbers, correct? And then you had irrational numbers, and those whole set make up the set of real numbers, right? Correct? So is every whole number also a natural number?
Yeah.
Is every whole number a natural number? Yes or no?
No.
No, why?
The zero.
Because of zero. Very good. Electronic devices should be put away, correct?
Yes, sir.
How many times have I said that? Put it away. In your book bag, so you're not looking at it. Or I'm going to move you up here by me. I will not tell you again. Is every natural number also a whole number?
Yes.
That is true, correct?
Correct.
Yes. And how do you prove it false? By a counterexample. The counterexample up here was zero, wasn't it? All you got to do is find one example that proves it false, and that's called a counterexample. This one here is yes. Every number is in the whole number, is a whole number, right? Every counting number, but not every whole number is a counting number, is it? And that number is zero, okay? Is every whole number an integer? Yes. Correct? Give me a number that's a whole number that's not an integer. Is 1 an integer? Is 0 an integer? Is 2 an integer? Is 3 an integer? Is 4 an integer? Correct? Now, is every integer a whole number? No. What numbers are they? The negatives aren't, correct? The negative integers are not whole. Is every integer number a rational number? That's true. Yes. Okay. Here's a set of integers. Correct? For those numbers to be a rational number, they can be written as a fraction, can't they? So how do you write -3 as a fraction? -3/1. So can't you write every one of those numbers as a fraction? Okay? Is every rational number also an irrational number? No. Give me a counterexample that proves that wrong. Give me a rational number that's not an irrational number. Yeah. Just give me one example of a rational number that's not irrational. Okay, the difference between rational and irrational. A rational number is, whole number or natural whole integers, right? And also decimals that stop, and decimals that repeat, correct? Those are all rational numbers. An irrational number is a number that doesn't repeat and doesn't terminate, correct? So is every irrational, give me a number that's an irrational number that's not rational. It's got to be a decimal, correct? Pi. There you go. That's one of them. Give me another one. Huh? How about the square root of 5? Correct? What's the square root of 5 in your calculator? You guys remember how to find the square root in your graphing calculator? Square root of 5. How do you find the square root? Hit second key and then x squared, right? Right there. And the square root's then hit 5. What do you notice about the decimal? Does it ever stop? Does it ever repeat? Now somebody says, Mr. Campbell, it stops. Yeah, it stops because this calculator will only do so many digits, but in reality, it keeps going, doesn't it? All right. And then does everybody remember how to find pi? Hit the second key, and you see right where this little power symbol is, correct? Hit that, and pi should come up, and then hit enter, and it should be 3.416, and keeps going. It doesn't stop, and it doesn't repeat either, okay? Now, what about this number? Hit the square root of 64. What do you get? So square root of 64 is not an irrational number, is it? Why did 64, when I took the square root, come out as 8? Because 8 times 8 gives me 64. 64 is a perfect square, isn't it? Anybody know another perfect square?
Square root of 25?
Square root of 25. Let's try square root of 25. Very good. So square root of 25 is a rational number, isn't it? Correct? What about the square root of 26? That's an irrational number, isn't it? Correct? Because you get a decimal, it never stops, never repeats. Okay? Questions? None at all. Okay. Is every integer also a real number? Well, you should already know that because all the numbers that we're working with in here are what? Every number we work with in here is going to be what in this class? Real. So this one's yes. Is every rational number also a real number? Well, that's also yes, because all the numbers in here we're dealing with are rational numbers. Okay? All right. Is every irrational number also a real number? I think we just said that, didn't we? Correct? Every number we're dealing with in here is in the real number system, isn't it? Correct? Is every rational number also a real number? That should also be what?
Yeah.
Yes. And is every whole number a real number? Yeah. Yes. Okay? Rewrite each number in the Venn diagram where it belongs. Always put it in the Venn diagram with the smallest set it's in. So negative 19, what would it be? It's an integer, isn't it? Correct? Correct. It's not a whole number, and it's not a natural number. Okay, what about 1.2, and it keeps doing this dot, dot, dot? What's that mean? What's the dots mean?
In order and
Doesn't stop and it doesn't repeat, does it? So what would that one be? Irrational. Somebody said, well, Mr. Campbell, doesn't that mean it repeats? No. It repeats if it's got a bar over the top. If it's got dots on the bottom, that means it keeps going and it never stops and it never repeats, okay? But if it's got a bar on the top of the number, then it means it repeats, okay? What about 0?
whole number.
Whole number, very good. It's not natural, is it? What about 3?
Natural.
Natural, isn't it? It's the smallest set it could be in. Is 3 whole? Yeah. Is 3 an integer? Yeah. Is 3 rational? Yeah, but the smallest subset it could be in is what? Natural, okay? What about the square root of 10? I think we proved that one. What is it? It's irrational, isn't it? And if you don't know, what do? Plug it in your calculator. Hit second square root 10 and hit equals. Well, does it ever stop? Does it ever repeat? Huh? No. Okay. What about 81? Plug that in your calculator. Tell me what you get. You get a decimal or do you get an integer value? I get square root of 8. Square root of 81 is 9, isn't it? So wouldn't everybody agree with me it'd be natural? Wouldn't that be the smallest subset? What about 3.456? That's rational, isn't it? Why? It's a terminating decimal, isn't it? Terminating. So rational numbers are going to be terminating and repeating decimals. Those are going to be rational, aren't they? Correct? All right. What about negative 4 over 11? Excuse me, I don't have my readers on. Negative 6 over 11, isn't it? Well, we should know right now it's a what? It's rational because it's a fraction, isn't it? But look what happens. If I put it in my calculator, I can prove it. What kind of decimal do I get? I get repeating, and aren't repeating decimals rational? Correct? But you should know all fractions are rational numbers. Correct? Okay. What about negative 1.4298 ... Irrational. Very good. Okay, what about pi plus 3? Well, let's find out. Hit the second key, pi, and then plus 3 and hit equals. What is it? Irrational, isn't it? Pi plus 3. What about negative 44? That's an integer. Is negative 44 whole? No. Is negative 44 natural? No. I told you to put it in the smallest subset, didn't I? Correct? So if 3 is natural, it's got to be all the rest, correct? But if it's up here, it can't be anything below, can it? Does that make sense or no? Is it getting a little easier? I hope. Okay, now, list all the classifications of this. So start square root of 10. What is it? It's irrational, and then it's real, isn't it? So that's all the sets it's in, correct? It's irrational and it's real. What about negative 44? What is it? Is it natural? Is it whole? Is it an integer? Yes. If it's an integer, it's got to be what also? Rational. And then what's last but not least, what is it? Real, correct? All of them are going to have real, aren't they? Okay? Makes sense? Okay. Number 3, what's it gonna be? What's the smallest number it can be? Natural, isn't it? It's going to be natural. It's going to be whole. It's going to be an integer. It's going to be rational. And it's going to be real, isn't it? Correct? Every one of those. Negative 6/11. Can it be natural? No. Can it be a whole number? No. Can it be an integer? No. But can it be rational? Yes, because all fractions are rationals, aren't they? Correct? So this one here would be rational. And then what else? Real. Good job. Okay. The first thing on the quiz, which you're going to have next week, well, really be the following week, because on Thursday, this is 4th hour. On Friday, you're going to take the NWE exam in here, okay? You guys have done that before, haven't you? You're going to take an NWE exam, and then you'll take another one in the spring, and they'll compare. Okay? So next Friday, you'll be testing in here, all right? Okay, so square root of 81, is it natural? What's square root of 81 equal to? 9. So it's natural. Is it whole? Yep. Is it an integer? Is it rational? And it's also real. 1.2 repeating. Is it natural? Nope. Is it a whole? Is it an integer? Is it rational? Yes, because rational numbers are repeating decimals. It's also real. Okay? What about 0? Is it natural? No. Is it whole?
Yes.
Is it an integer?
Yes.
Is it rational?
Yes.
And it's real. It can't be both of these, can it?
Yes.
All right. If it's irrational, then it can only be these two, correct? Okay, what about negative 65 thirds? What happened? Can you see it? I'm sorry. Thank you. Negative 65 thirteenths. What is that? It's rational, and what else? Real. Can't be these because natural, whole, and integers aren't fractions, are they? Or decimals. Thank you. If a number is an integer, then a number is also rational. True or false? That's true, yeah. Correct? Look, right here. If it's an integer, it has to be what? Rational, correct? If a number is real, then it's also rational. Just good. That's false, because if a number is real, it could be also irrational, couldn't it? Right? Agree? That one's false. 3.456 is an irrational number. False because it's a terminating decimal, isn't it? Square root of 11 is a real number. That's true. All the numbers in here we're dealing with can be real numbers, can't they? And 0 is a natural number. That's false. Nine is an integer. Is that true or false? It's true, isn't it? If a number is natural, then it also whole. Yeah. Name a number that is an integer but not whole.
-3.
Very good. -3 or -2. Correct? Or -1. All the negatives agree, so this one here is false. So name a number. Let's just put that here. Name a number. You said -3. Okay. Give an example. An irrational number was not already used on this worksheet or our notes. Give me an irrational number. It's going to be any square root that's not a perfect square, correct? So the square root of 19, right? Let's check it. Go to my calculator, hit second, square root 19. Do I get a decimal? Doesn't repeat, doesn't stop, right? Yeah. But the square root of 25, it stops, doesn't it? So that's a rational number. You guys see the difference on the square roots. If you get a decimal, then it's irrational. If you do a square root and you get an integer, it is rational, isn't it? Okay. Write the number 0, write the subset Q, which is all the even numbers. So all the even numbers are what? Numbers that are divisible by what? 2. Is 0 divisible by 2? It's not? Yes, it is. What's 0 times 2?
0.
Yeah. Correct? So my new subset would be 0, 2, 4, 6, 8. Put the following numbers in descending order. So we're going to change them to what? Decimals, aren't we? So now we're going to use our calculator. So we're going to take 276 divided, was that 13? So 276 divided by 13. And kids, somebody, I'm going to round it to 3 places to the right of the decimal. Does anybody know why I'm going to round it 3 places? Because that one there is at 3 places. Does that make sense? So I'm going to round this first one to 21.231 or 21.230. We'll just say. That was the first one. Okay. 29, is that 20 pi or 29 pi? 29. So 29 gets second. And then pi is this little key right here. Pi, and it equals, and I get 91.106. And then the other one's already done, isn't it? Correct? Yeah. And then square root of 225 is a perfect square. It should be 15, right? 225 is a perfect square. And then this one here, I'm going to put parentheses. You guys see where parentheses are at on your calculator? And then hit 2 minus 5 times 2, close parentheses. Now, that's an exponent, isn't it? Everybody see the exponent too? So hit the upside down, this little upside down V. That gives you an exponent. And then hit 2, and then hit enter, and I get 64. Everybody see where I'm at? This should have been a decimal here, shouldn't it? Okay, so which ones? It says in descending order, so we want the biggest one first, don't we? So which one's the biggest one? 124.2. Yeah, so that's going to go first. 124 points, so I'm going to get rid of that one. And what's next? 91, so that was 29 pi, right? Because remember, you're going to write them back in the original form. So we got that one, don't we? What's next? 64, which is this one, right? 2 minus 5 times 2 quantity squared. It's that one. Then it's this one here, right? Which was 276 over 13. And then what was the last one? 15, which was the square root of 225. Does that make sense? Does everybody see how I did that or no? Huh? Questions? Change them to the decimals, put them in order, and then change them back to the original. We okay on that? We're going to do these and then we're done for today, and I'll let you do the rest, okay? All right. This symbol here means subset. This little C, squeeze down C means subset. Okay, so here's your original set. Is 2, 3 a subset of that subset up there? Is 2, 3 in that subset? Yeah, so this one here is true. Is A, which is this up here, a subset of this set? Well, are all those numbers in that set?
Yes.
Here is A in that set. Yeah, it is. The only number it's not is what? Now, this one is not a subset of that one because 7's not in that one, is it? For it to be a subset, all these numbers here have to be in that one. But this one here is not a subset of that one because this one doesn't have what? 7. Do you see the difference? This is a subset of that one, but this one is not a subset of that one. Does that make sense? For it to be a subset, it has to have all its elements in the other set. for it to be a subset. So that is true. Is 8 a subset of A? Is 8 an A? No, that one's false. A is contained in the set 3, 5, 1, 7. That's false. I mean, is every one of those in that set there? Some of them are, but not all of them, right? Correct? False. Is 1 a subset of A?
Yeah.
Yes, because 1's an A. That's true. Is 1, 2, 3, 4 a subset of A?
Yeah.
Yes, true. So I'll let you do the rest on Monday, for Monday. And then I'll check those 2 worksheets, keep them, and then you'll get 10 for each one. Yes, sir. For which one, F? For which one? Did you get an answer or not?
I did.
9 is an integer. Is 9 an integer? No, an integer is all the whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then all the negatives and those too. So the integers are going to be this. Remember, it keeps going. Correct. So what I always remember, an integer is whole numbers plus all their opposites. 0 doesn't have an opposite. Does that make sense? The rest of that packet. Okay, the question was, let's finish that packet, and then I will check both of them on Monday for 20 points, 10 for each one. One that you did for the day, and the one that we're doing now. Okay?